will keep this as in our repository for the startups to refer as and when required. Thought I should make this clear. Samantra is here. Should we start or?
Yeah. Sure.
Yeah.
So, I
think your voice is very feeble. I'm not able to hear very clearly.
It's not audible.
It is, but very feeble.
Very feeble. Okay.
Yeah, unlike Upasana's, it's very clear. Yours is very feeble.
Let me do something. Just give me a minute. I think there's some background noise. They will just fix it in a minute.
No problem. Now it's clear. It's clear. It's better.
Okay. Yeah. So, good afternoon, everyone.
Yeah, I'll just quickly introduce and then we start.
Sure.
Yeah. So good afternoon and namaskar. Thank you so much, CSM, for being our partner in this mining challenge program. And today we have with us Shri Nilabdi Samantrai, AVP Science and AI Delivery, CSM Technologies Private Limited, and Ms. Upasana Mahapatra. She's the business system manager of CSM Technologies Private Limited. I thank you enough. Just for an introduction, Electropreneur Park is organizing this Pan-India acceleration program for startups and innovators, which focuses on solutions in this mining sector. When I say mining sector, we are looking at technology solutions that will help solve the predefined problem statements that we have received from our partners like CSM, NALCO, JSW, RS, MaxByte, Happiest Minds. And the objective of this acceleration program is to address the problems that is faced in the mining industry by technology intervention. And this would enable the startups and innovators pan-India to convert their innovators' ideas into an implementable product through the constant mentoring and the technical support that you would be receiving during this program. And this will mainly aim at scouting the solutions of the problem statement, which is provided by the industry partners, like I said, and considering that these ideas and applications are a major objective, the program also aims to create a conducive environment towards the practical implementation of the solutions that come out of the program. So what we are basically looking at is with the support from our partners, the winning solutions will possibly get piloted, implemented in real life. And because our objective is to bring out the state of the art made in India solutions. So the problem statement that got listed might have an existing solution to it, but what we are looking at is from the perspective that it should be a cost, like it should be driven by the right cost and the right technology, and also the most important of them is it should be a made in India solutions. So there has been rapid advances in technological innovation, and CSM is leading in digitizing the mining industry through its different various product suites. And that helps both mining industry as well as governments and other mining agencies to have a clear picture of the ecosystem. Be it bidding or extraction or reporting workflows. You please correct me if I'm wrong. I know you have different products in this UAV surveillance system, in stockade management, in mines and mineral management system, and to name a few. So you will be the right partner to help the startup selected through this program to develop the right solution to the problems. The focus areas is a reduction in energy consumption cost in mining, data-driven solutions for optimized operations, health and safety, reduction in environmental impact and carbon footprint, water quality in mining, and mining transportation. You have provided, CSM had provided with 9 problem statements, but then some of the statements got merged in the other problem statements. So you can please feel free to discuss on all the 9. And but the exclusive ones are real-time probe collection and risk management using sensors, RFID for temperature, humidity, flooding, and other inputs in real time for underground mining. Blockchain-based provenance and carbon footprint tracking, mineral trace and track solutions for nighttime. Example for riverbed minerals, underground mining traffic control management solution for mines. So the rest of it we merged it in some of the similar problem statements, but please feel free to elaborate the problem statements so that the startups can take this as a reference and design according to the requirements of the industry. Over to you. Thank you so much, Mr. Samantran and Upasana, please.
Thank you very much, Lopa, for the detailed introduction. I think it was pretty exhaustive. Thanks for that. We will, as you have already introduced myself and Upasana, so maybe I will request Upasana to share some slides that we have. That
Sure, sir. Actually, sir, I just have, if you could check your message box.
sure,
I'm having trouble pulling up my
no worries.
deck over here. We'll
Sure.
proceed.
So just give me a minute. I will put it on the screen.
Sure.
Yes, I've received it. So let me just try to put it on the screen. Okay. So let me share. So is it visible? Can we see what I see?
I'm able to see your screen.
All right. Okay.
If the poster that is what yeah, introduction, yes.
Yeah. Okay. Yeah. All right. Hello everyone. Hello again, and just a brief of about the introduction about organization where we work. So we are called CSM Technologies, which is it's been there since 1998. We are 1,300 plus employees, spanned across multiple locations. And we have received CSM Technologies, CSM, we have received multiple awards and recognitions both at state and national level and international level. We are there in the business for the last 24 years. And predominantly we work for GovTech solutions while we work for enterprise clients as well. But around 80% of our clients, they are government clients from India, state government, union government, as well as clients in Africa, Middle East, and the US. So we work across different locations on this. These are the key, just to give a brief about who we are. So these are the kind of services that we do, where our key focus right now is emerging technologies, where we do a lot of things with big data analytics, advanced analytics, artificial intelligence, machine learning, geospatial technologies, RPA, and cognitive solutions that we work on, apart from traditional enterprise resource and planning and enterprise application services that we provide over cloud. Our key partners across the all OEMs that we have. Now, yeah, I spoke about our presence across India, in the Middle East, Africa, and the US. Yeah, so we are around present in 7 countries in Africa and then in US. So that was a brief about what we do. And here we are trying to address some specific problem statements which we identified while we were working with different clients. So as I said, we work with one is regulatory clients, that is the governments, as well as the enterprise clients. The enterprise clients. So our problem statement and the solution came from our experience with both kind of clients that we came across. And I would now request my colleague Upasana to take you through each of the problem statements, and she will run you through while we come across we talk about different areas and use cases we came across during those problem statements.
Sure.
Upasana, are you there? I think I just got a call from Upasana. Did she drop off?
Yeah, I think she dropped.
Oh, let me just let me call her. I think let me. Otherwise, yeah. Okay. Since you are nearby, why don't you walk in and to my chamber, and we can, and if that's fine with you, yes, that'll be. So Lopa, some issue with Upasana's system, I think. So
No problem.
Yeah, I think I'm back on. So sorry, everyone. There was my system froze. I hope we did not miss a lot of it. So without further ado, I think we should jump right into the problem statements that we are talking about. And the general understanding around all this problem statement is that it is coming from a very raw place. For example, there are a lot of industry problems that we have been dealing with, we have working with for the past 10, 11 years, as my colleague Mr. Nilabdi mentioned. But there are always more to look into, especially in a domain such as mining, which actually in itself is a multidimensional area. This is a very evolving thing, and so please understand that the problem statements applicable over here is vast in nature. So if you ask somebody who has been working in the mining domain, there is a lot of nuance to it. So here we are talking about the problem statement which are more or less all encompassing in nature. For example, some of the problem statements you would see will be applicable to certain kind of mineral. For example, mineral found in the mineral bed, riverbeds, or certain areas where the major mineral, which is essentially any kind of non-coal mineral like iron ore or bauxite, etc. Those will be the big lookout area. And apart from that, there are a lot of persistent problem which we see around ourselves, which is a general underlying tone which is applicable to mining operations as a whole. For example, the problem statements around material tracking, provenance detection, etc. So I hope this basically clarifies as for where are these problem statement coming from. It comes from a very diverse background per se. And the second part that I would like to talk about, just allow me to pull up the presentation here so that we have something to refer to as we walk through. Just give me 1 second. I hope my screen is visible. Lopa ma'am or Nilabdi?
Yes, it is visible.
Great. And the second, basically a general, more of an overture that we would like to mention is some of the problem statements have been mentioned here include a certain suggested, set of technology stacks. For example, we could be going for, suggesting or going for using blockchain for tackling the problem of material tracking and provenance. While it might just happen that any startup or any group who is taking up this challenge would be they have a different approach to the same problem. So I think that is a very fine thing to do. Of course, the more ingenuity there is to the solutions, the better it is. And as Lopa ma'am very precisely put forward, we are looking at very real life. Of course, it will be based off of a lot of proof of concept and proof of value. to the real life implementation full-fledged. But obviously the marketability, the economics of the solution beats any kind of fancy technology stacks that may or may not have slipped into the problem statements. So having a very clear clarity over what has been actually asked of the problem statement, as opposed to going by the suggested ones, that is always left to the discretion of the participants. So these are just two bits that we wanted to put forward to it before jumping to the problem statements right at it. The first problem statements, if you refer to the dossier circulated by STPI, was I think the problem statement number 25, which is essentially a reliable mechanism for manpower tracking in mines, especially underground mines, from a safety and optimization purpose. So this falls directly in the in the line of vision for the overarching mine MCP underlying that was in place. So what happens is in most of the mines that we see today, which are operating underground, because be it the nature of the deposits present, or be it the nature of the economics of certain mine mineral operations, it becomes very difficult to track certain assets or even manpower who still have to go to those frontier paths to either assess the environment or undertake certain mining and mineral operations. A lot of things have changed in that direction. Of course, there are heavier moving capability, material handling sizes have increased, but the trace and track and the kind of safety that is prevalent in most of the open cast mining operations is vastly different from what we find in most of the underground mines. So we have had the good fortune of getting exposed to those areas and to look at those problems very close. This is particularly prevalent for certain underground mines in areas like the south of the country, where the coal deposits, the seams are not particularly thick, and in order to make any of the operations, mining operations, economically make sense, they have to have a an underground mechanism to extract the coal, rather than running some OCPs or the open cast plants. So this is exactly was one of the problem statements which we were we found, and we are still working on it. And this is essentially to make sure that the people who are going down the shafts, or at least going to the parts of the mines in the underground mines, they are basically, they have a better channel for communication. The tracking becomes very important at any point of time during the work shifts and all. It should be the secure channel for communication becomes the lifeline of people going down there. So the problem statement is basically to find a complete end-to-end solution as for how to the tracking and communication mechanisms can be handled. So that is the entire premise of this problem statement.
Poor network also will come into the picture, the poor
Absolutely,
connectivity.
absolutely. Because today, if we see most of the open cast places, they have a lot of provisioning in terms of internet availability, or even like asset to asset or manpower to manpower communication. But that is not the case, and at least without burning a hole in the miners or the enterprises pocket, it is very difficult to set up reliable and sustainable networks down there. So there are a lot of momentum in that directions. There are certainly with the advent of technologies like LoRaWAN, etc. So these things have actually slid down to a medium priority things for the surface level operation. But for underground mining, unfortunately, that is not the case. So this is where the communication from a tracking perspective becomes important. So be predict any rescue operations, which unfortunately is way more prevalent in underground mines, or maybe even just to keep track of where is the manpower deployed currently, what is the kind of risk that they might be facing in those environments. All these parameters become part of something bigger there. So our problem statement number one basically brings up this challenge of how to optimize and how to purposefully put all of these things together. Shall we move on to the next problem now?
Yes, we should. We should.
Okay.
Because we'll be coming back to you only when the startups refer to this and come back with questions. So I'll definitely be putting forward the questions to you for the
Absolutely, absolutely. And that is I believe that is the entire purpose of having this, taking up the mentorship part too, where we believe that as a company, we would be able to get some, context to what is relevant to the, current scenario in the mining or in the industry. And obviously startups are the one where they get a lot of good ideas, and obviously the implementability is up for tests. So we certainly look forward to that. This is the second problem statement, and the dossier said.
For the previous problem statement, do you have a background mentioned in the slide? Because if you can have this,
no, there was no background, but I'll share. There is an additional piece of documentation done around this. After this particular session, I would share certain more material around it. So while we might not have the specifics or the technicals of it packed down, but that is the entire point of problem statements.
Maybe we can post that for the startups to refer the reference.
Absolutely, I'll post that right after this. Is that all right?
Yeah, absolutely. Please proceed with.
Okay, great. So here the problem statement number 2 is, comes from a part where, essentially mining or mineral or mining operations, they are, very handy with things like handling material or, dispatch and basically any kind of logistics in and out of mines. But there is another very important cog in that wheel, where you can say that both the government as well as the enterprises are very much reliant on it. That is basically, we are talking about the sampling and testing part of it. Any mineral today that we see, and especially in the context of states like such as ours, like Odisha, Jharkhand, Bihar, Chhattisgarh, etc., a lot of the royalty realizations that the government come up with comes from high value, high volume minerals like iron ore. And there it becomes very pertinent for them to know what is the quality of material that is getting dispatched. Obviously a lot of state have different rule sets around it as for what is the royalty applicable on top of it, but certain entities, certain regulatory bodies, including the Indian Bureau of Mines, they do have certain provisions around how the royalty should be applied based on the grade and the type of mineral. And when I say mineral, it is basically the mineral ore per se, that is the iron ore in this case. And based on the iron content of it, there are different slabs done as for what is the applicable royalty. But then again, if one has to look at a complete life cycle of what happens once the material is extracted and then it is readied for processing, maybe some kind of preliminary processing like screening and crushing, and then moving the saleable ore to readying it for dispatch to the end customer. There is a very unique piece there which includes reporting all of that to the government and paying the royalty due. And how does the royalty gets calculated? It gets calculated based on the iron content or based on the mineral content of the said ore. So that is where the things regarding the sample and the testing or the grade determination parts comes into the foray. So what the problem statement essentially focuses on here is the traditional wet chemical analysis of any of these mineral ore. Essentially, we are talking about iron ore over here, because for coal and other things, there are different, approaches available. So wet chemical analysis is the way to go, but it is time consuming. I mean, just to put it in context, if a material is extracted at T0, then it at least takes about 3 to 4 hours to get the testing done alone. Plus, there are certain processes around collection of these samples, then taking it to the labs, and then there a certain kind of procedure is followed in order to create smaller and representative samples out of it, and then taking it and testing it to find out the iron content in it. So it is a long and lengthy process, and the starting from the collection of the sample to its reporting of the grade can take anywhere between 4 to 7 days now. So as you can see, this is kind of a very laggy kind of a situation, and this is something that even the governments as well as the enterprises, they have been investing very heavily to look at alternative technology stacks. One of them is the either the XRF or the XRD. So both of these technologies in different form factors have been used for a while. Mostly, a lot of entities who deal with end products like steel or anything with a homogeneous constitutions, they have been using it for some time, and the results are actually very accurate. But in case of mineral ore per se, the things become a little bit tricky. So this is where the general disclaimer that I put before, that do not worry about the stacks or the technology which we have suggested over here. These are mere suggestions, but if you take the spirit of the problem statement, this is what it is. Even though XRF and XRD are very promising pieces of technology, but they aren't proven that very ready, like you buy today and use tomorrow kind of technology pieces. There has to be some right set of calibrations, and again, the repeatability of the tests that you could run on the ground with a smaller form factor, like something like a handheld XRF device or something like that. It can get really tricky. So this is where we are looking at a possible solution where we are able to leverage these kind of technology or technology similar to it by basically bringing a cap on the entire time that it takes for the sampling and testing. So this is what the problem statement is. I hope that clears it up.
Absolutely. I am myself getting literate on the mining industry now. Thank you. Thank you. This is very clear. Yes, please.
Okay. Great. So I'll talk about the next problem statement, and I'm trying to get it done as fast and as quickly, so that if attendees are viewing it on YouTube at a later time, so they do not have to expend a lot of time on researching and what it is, what it isn't. So yeah, if there are any questions or any kind of clarity, please feel free to reach out. The third part is, it might look very terse, but this is also something very new that we came across, and which is essentially detecting the thermal signatures on the mineral, which is carried from one part to the other. So a little bit of background here, that what happens is, in case of certain riverbed mineral or minor mineral, as we call it, in case of India, things like sand, or it could be gravel, or basically any kind of laterite or clay, etc. These things also support a big part of the entire mining and mineral economy. And while they might seem like not as valuable commodity as things like zinc, bauxite, iron ore, or coal, they do have a very important place in the entire mineral value chain. So goes without saying, of course, consistently it is the management and the regulation around these kind of minerals has been on the governments themselves. And since we work with a lot of departments, mostly mineral and geology departments of various states, So this is a consistent problem for them. As for how to tell what mineral is being carried from one place to other, how do you trace and track? How do you make sure that there are very few leakages in there? And the idea is not to like bring in surveillance of all kinds, but the kind of practices or malpractices for that matter, which are prevalent in case of minor mineral, it is absolutely baffling. So recently we came across this particular thing where we were asked to come up with a solution which is able to detect the thermal signature present in certain mineral. It could be, for the matter of this discussion, mostly riverbed minerals, to say if it is, really a legit piece of, consignment, or is it, there is something funny going on. So this is more of a long shot there, but then process-wise, if you look at it, there is a lot of checks and balances that the governments have already brought in. Any kind of commodity exchange that happens in a well-governed state, it happens through a channel of entities only, who we call as the licensee holder or the lessees. So not everybody can buy and sell mineral as the whole. So that is something systematic that was brought in place. The second is the layer of technological intervention. Basically, you get better channel for communicating if there are any malpractices going on. Then obviously you have technologies around drones or satellite imagery, where you are able to detect as for if there is any kind of mining activity going on in the illegal places or places that are not earmarked for for mining, or all these things are covered under different hierarchical treatment. This is one such things which is more granularly placed with the operational side of it. So most of the mineral transaction that we see, at least in case of sand or gravel, it happens through vehicles, including your tractors, tippers, trucks, etc. There are really no standard way of doing it, and actually the law allows that.
Yeah,
So
we have a problem statement, pilferage in mining areas. I think this also is a part of that, right?
yes, absolutely. There will be certain overlaps, as you rightly said. The initial problem statement were 9 in number, but there were some overlaps there because assets and everything are consistently the big buying areas. So this particular thing is something specific that we came across, which also piqued our interest. So let's see how the participants take
Absolutely.
on.
Yeah, we definitely would like startups to apply for some specific problems so that that gets implemented, because that is where we would like them to go.
Absolutely. So anywhere where the mineral is not visible to the naked eyes, there could be, you can put up, the governments actually have put up a lot of checkpoints. They have designated flying squads who are consistently doing rounds and checking if every mineral consignment is being is a verified one or a royalty paid or one. But what do you
In
do
fact,
about what do
yes,
you
yeah.
do?
In fact, yesterday only in one of these sessions with one of our partners, Happiest Minds, exactly they were talking about the diamond theft and all.
Oh, that's
Yes.
that is
So I think
something.
this is especially for the riverbed minerals
Yes,
and
this is especially for riverbeds. Yes, although the source from where this problem statement comes from, I mean that state or the department, no names taken. They are primarily into riverbed minerals only. So not a lot of iron ore or any of the major minerals as we know it. So that is where it is coming from. Sensing it from the top without having to look at the mineral. That's the idea. So I'll move on to the next problem statement, ma'am, with your permission. So the next one is the real-time probes for collection and risk management. Actually, this is one area where Nilavdi sir takes special interest into it. So I think I will pass the baton to him to take this one up.
Upasana, definitely we put in a lot of interest out there. So thanks, Upasana. Typically, so there are two kind of mining that happens. One is open cast, as Pasna said, and one is underground. And underground mining has a lot of issues like about the ventilation parameters, the oxygen levels, the temperature, the humidity, the gas concentrations, and even flooding, which happens. And these are basic safety matters for people who are working underground mines. And we can come up with some innovative solutions. In fact, there are few, and there are startups can do a lot of work out there wherein they can use sensors and RFID, wherein we are able to send on real time different probes on the temperature, humidity, flooding, or the gas concentration levels. That will ensure that rather than a reactive action, it can be a proactive measure can be taken in order to avoid any kind of accidents or any adverse safety incident that could potentially happen. And in order to do that, there are technology available. It's like you have to come up with some solutions. Technologies like underground long range radio or LoRaWAN can also be used, where there are physical or communication settings with different bandwidth and spreading factors, which can be used for underground because internet and other things becomes a challenge in underground mining situations. So the different RFID based sensors can be taken or leveraged in those kind of situations. The sensors can send a probe on a millisecond basis and proactive action accordingly where there is an evacuation need for human beings working there, or there is some temperature modification that needs to be done, or there is some humidity changes that needs to be done. All that can come on a real time basis, and that is what we are looking for, some kind of solutions. And there are some enterprise miners who look for such similar safety solutions to be available. I'm sure there are a lot of startups who would have and would be coming up with some innovative ways of how a package solution can be made around it in real time for underground mining specifically. That is a brief about what can be done in this area. So yeah, I think that was a bit about what can be done in underground mining, typically like a copper mining or even for other mining where it's not open cast. These solutions can be done. So over to you, Upasana.
Thank you, sir. So this is actually one of the wonderful problem statements that even our own teams, our own R&D teams have been working for some time. So just the name of the game is basically leveraging not just hard sensors, but at the same time look at all the process parameters and come up with some very ingenious soft sensors as well. So that borrows a lot from a lot of concepts that are built around even data analytics. So that is a very blooming space.
Yes,
To,
actually, that reminds me of Upasana. So, in the month of March this year, I was in one of the that's an annual mining conference that happens in Utah, in US. So I was there where I attended this mining conference, wherein they had come up with a drone, which drone was a auto pilot. I mean, there was no pilot required to run it. It will go inside the underground mining area to figure out what is going on with its cameras and sensors. Probably I have a short video on that. Maybe after we are done with this, I can show you that as well. The person who is the owner of that drone company talks about it. So yes, that was one of the innovative solutions where unmanned, because the drone itself runs without hitting on the wall or anywhere because it has its own sensors, just like a Tesla car kind of a thing. So that was one of the innovative solutions that was done by one such mining enthusiast. Yeah.
Absolutely, absolutely, sir. I mean, as interesting as it sounds, because it's just about tweaking the payloads on such unmanned, drones and other things without bringing a lot of risk to, manpower and workforces. So, but obviously, we are supposed to talk about the problem statements and the challenge here rather than the solutions or the probable solutions. So, we'll let the participants decide what's the best way to go forward with it.
Yes, sure.
So quickly to the next one. This is actually, it's less of a specific industry specific thing rather than rather it is something which is prevalent. You can see it at the lengths and breadths of most of the industries today, even IT included. So here the provenance that we are talking about is essentially tracking the origin of something. So most of you must have had, since this is a very globalized and consumer-centric marketplaces that we are seeing around today, you can always find, certain thing, in a supermarket which is marked with, okay, made in Thailand, packaged in something and imported to India on such and such date, right? And it's amazing how the entire thing works out. I mean, we are talking about something, from an avocado to maybe, a fancy set of fish that you don't find in this geography. It's absolutely amazing and. All thanks to globalization as a gift that keeps on giving. This is actually, a very prevalent, problem or pain areas, even in case of mining and mineral sector. So most of it, as you see, the underlying is any kind of mineral ore. You talk about coal or any kind of non-coal mineral. They're always going to be in a bulk nature. Their nature is that of a bulk. They are mostly, not, in a unit which is, very friendly with the provenance tracking. So this is where how exactly do you go about handling those consignment which are originating from a certain areas which may or may not have a very good history with the carbon footprinting or extracting mineral sustainability. This is actually quite a unique topic which is still a matter of conversation in a lot of forum, mostly in the African continents where there are it is basically a very mineral rich area, but then due to the sustainability issues or due to various practices which are very damaging to the environment as well as the people who are living over there. This is a consistent problem area that we see. And to boil it back to how this can be addressed with the help of technology is one of the few things in the last year that have become quite a rage, that is the blockchain technology. Of course, a lot of people also have attempted this to do it with a distributed database kind of a system, where it is way more economical, or there is a chance that there is a break even for those two very competing set of technologies. So we leave it up to the participants to determine. But
Yeah.
essentially, from a quality perspective, it is something which is a major ask for a lot of big miners as well as the customers who are buying material from them. From the quality perspective, the buyer would want to know, from where the mineral has been extracted from, how many hands it has exchanged, what is the aging parameters of all of this, and obviously, how much of it is, faithfully preserved. Have the impurities, how they have been depressed, or what is the aging parameters for the commodity which is finally reaching to him. So, yeah.
Yeah, so personally, I think it's a blockchain-based provenance wherein we can guarantee from where, which pit to which plant or which port the particular ore grade material is going on. That kind of reminds me of the use case, the Colombian coffee or the Indonesian fish of IBM use case, wherein you're eating a fish in a New York restaurant and you know exactly which pond it came from in Indonesia, something like that. That
Absolutely. Absolutely. So that was problem number 5. Now, problem number 6 is more of a broad-based kind of a solution, where we are saying you can see the glimpse of something that we had covered in the previous problem statement. I think problem statement 2, where we were looking for thermal signatures on the covered vehicles and how to tell what kind of mineral consignment is going from there. So this is more of a end-to-end flavor to it. For example, if you're talking about mineral extraction, it is it might might look like a very unassuming pieces of industry sector, but believe me, the operations are tedious. They go on often at like 24 hours, and they are truly like the backbone of this economy, if that's not a hyperbole by any extent. So here what happens is most of the both legal as well as some of the illegal mining, they are undertaken in the shroud of night time, where the visibility is low, where the allocating resources or manpower to certain sensitive areas where such transactions or malpractices are suspected, that basically gives a lot of room for all these kind of things to thrive. So the governments are almost always on a lookout for solution which basically elevates this kind of problem through various mechanisms. So the background or the parameters that are in play over here that one must understand is one just cannot walk to a source and then extract it. It has to be sustainable. It has to be done in volume, and obviously the obvious loopholes in the systems, if there are any, they will be leveraged by the culprits or the suspects. So how to come up with an expansive solution that makes sure that the assets or the basically the handlers who are aligned with such activities are consistently monitored and are basically brought to the books. The riverbed minerals, why? Because they are the most susceptible ones, as opposed to other deposits like iron ore, etc. You can find riverbed minerals in the form of sand pretty much everywhere, and this is of course there is out in this is very much out in the public. But sand mining has degraded the quality of environment as well as a lot of things for a lot of states. So including the governments as well as those who are legally into this sand mining or gravel extraction business, they suffer a lot because of that. And of course, environmentally speaking, also there's also there are a lot of risks involved. So a trace and track solution over here basically ensures that government has or the regulatory bodies have a way more decisive view of how things are happening during the night time. So any mix of technologies, be it any set of camera technologies or be it some kind of tracer tracks or sensors, low cost sensors which can be placed anywhere, or basically any regime that involves a certain kind of monitoring, be it airborne or surface level monitoring, those can be done. That is, those are the tentative areas or approach to the solution that we are looking at. Anything to add there, Nilabi sir?
Yeah, I think that was a pretty important aspect where we want to ensure with some innovative solutions on mineral trace and track, which has been a pain area for, as you rightly pointed out. It's not only about the least bound area where the extractions would happen. So in riverbed, it is very difficult to keep that geofenced area intact. And since it is not like a major mineral where you have in gate and out gate, it's a riverbed. So unless you use some technology solutions, so there can be a lot of leakages across the riverbed area or the lease bound area which was provided. And then that there are other kind of challenges also, like tractor trolleys and all, which doesn't even have a number plate, but it is allowed to carry on the mineral. So that's where we should have some startups come up with some certain innovative solutions. And the demography also keeps changing in the riverbed because of rain and other aspect. So that's the thing I wanted to add, Upasna.
Absolutely, absolutely. Thank you for pointing that out and adding that. It's actually a very prevalent one. So the profile changes are also something, which is very tenacious and consistently needs looking after. So, and of course, once this is the last problem statement. Just give me 1 second. Yes, this is this. actually borrows from the how the traffic is controlled in most of the high volume underground mines. So today, if we see the open cast mining has become very prevalent, mostly due to the fact that the asset allocation, material handling are way more easier to do on surface rather than doing on the at the underground level. But of course, we have very distinguished enterprises who have found a way to make the economics work in case of underground mining, and most of the high value, low volume deposits that you see, such as like zinc, etc., those are almost exclusively underground. So, but the thing is, managing the assets which are going into the mines or the manpower that are going into mines, they require a very tenacious, very reliable, and very efficient system to control the traffic. As for what goes in and what comes out, and whether they are loaded or unloaded, or if they have to basically, make a dash for maintenance, or what is the kind of, assets, what is their, utilization or performance has been. All of these things are, something which is very relevant to the teams who are working on the mineral mining operations. And one such thing is the traffic control system. So this can happen on multiple ways, of course. We are talking about any, underground mines which are, which are not very deep in nature. We are talking about around 300 or 400 meters below RL. And of course, such systems have to be very reliable. So one of the underlying assumptions we would understand is the presence of good connectivity or some form of communication between the last frontier on the control panel on the surface. So this is what the problem statement is. Very straightforward. Certain things that can happen on surface do not happen the same way on underground. So there you have to be particularly invested into making sure that not only the collision courses are well taken care of, but at the same time the vehicle movement efficiency is not reduced. So this is where the true genius behind any solution will lie in. That is one part. And that pretty much actually covers the entire thing. Nilavi sir, if you have to add something.
Yeah, I just wanted to add, as Upasana said, there is a different challenge in open cast versus underground. In the underground, the tunnels are they're not very broad, they're thin. So the mineral carrying vehicles and trolleys, it's very difficult for them to cross each other because one has to get into a docket before the other one passes. And that is where you have to come with a proper traffic control management. Otherwise, if any kind of traffic jam inside, it really it takes a lot of efforts to dismantle the whole mess. So, an effective traffic control management is very important in any of the underground zinc or chromite or any of the underground mineral uh, area. So, just wanted to add that. I think that covers the 7 problem statements, which practical interlocking with the different clients and enterprise as well as regulatory we came across. So I think that's it.
And one more thing that I would like to mention over here is participants who are looking forward to invest themselves in solving these very problems. I think the mindset should be more around that the solution should not be bigger than the problem itself. Why? Because obviously, I mean, this might come across as something, straight out of common sense. But believe me, sometimes we have come across solutions which are actually worse than the problem. So that basically takes care where you are. You should be engaging with the mentors more and more to understand. Even we learn as we interact with you guys, and we understand. Since we have an exposure to the industry and our customers. So that is point number one. And the second point is obviously don't go for perfection in the first go. I mean, it might sound very cliched, but there is a saying that says that, best is the enemy of good. So That is where we should be looking at more iteration to a certain solution or a certain prospective solution per se. So these are, I think, the items that we wanted to just put it out there.
Well said, Upasana. In fact, that also reminds me, as what you said. It doesn't have to be always first of a kind solution. So as Pastor said, the solution should not be bigger than the problem. So it doesn't have to be always the FOIK kind of a solution. It can already be existing, say some other country. But what we need is a make in India. I mean, which is more the available, easily available in India. You can always do that and so add some innovation to that. Invent something new as well, but at the same time, if there is some happening across the globe somewhere else but not yet in India, so you can definitely have.
Let the startups be inspired, but make their own. Yeah.
Yeah. Yes, of course. They're also inspired is the right word, because innovation is always on top of what exists. So that is what I want to highlight, because reinventing the wheel is not a smart thing. So if there is a problem statement and if there is some solution which exists somewhere else, so you can always make innovations on top of it. That's what I wanted
Yes.
to
Yeah,
highlight.
that's why I did mention that there might be existing solutions to the problems, but it is how can you better it or add your own salt and sugar to it,
Or even the
product that we are looking for.
marketability of it, if you ask me.
True, true.
I mean, that is, for example, YouTube happened like at least 5 years before any of the OTTs become famous. But why exactly the OTT platform stuck around is because of their subscription model. So, and of course,
You, I was about to say that Facebook is not the first.
exactly.
There
So
were many. Trust me, there were hundreds and thousands, because I also had one of those before Facebook. So
yeah, we had Orkut and all. I remember
yeah.
long back. Anyways, let's hope to get some good startups and startups that should be coachable by you and your team. So we look forward to such startups and some solutions that can really be implemented and help in solving the challenges faced in the mining industry. Most of our revenue comes from the mining industry, so it is high time we involve technology into it and make things happen.
And take forward the Atmanirbhar Bharat.
Absolutely, yes. Thank you so much for your time today. We'll be in touch, especially for scouting the right startups during the screening of the applications, and then take it off from there in mentoring the startup.
Yeah.
Thank you.
Thank you. Thanks so
Thank you,
much.
ma'am.
See you too.
Thank you, Nilam. Thank you.